let L be a mapping from the rails into the rails. Be defined by L of u is a scalar multiple of u plus a constant. A and B are real numbers. So we want to find the values of A and B such that L is a linear transformation. So how about we apply their definitions of linear transformation. Let U and V be in R1. Okay, we want L of U plus V. Now that's one vector. So it's going to equal to A times U plus V plus B. We want this to equal to, this is what we want. We want it to equal to L of U plus L of V, but L of U is AU plus B, plus A of V is AV plus B. So what we want is this, we want this to equal this. So A times U plus V plus B, this is AU plus AV plus B. And we want that to equal to this. AU plus B plus AV plus B. Well, I can cross out AU from both sides. I can cross out AV from both sides. I can cross off B from both sides. The left-hand side is 0, and the right-hand side is B. You want B to be 0. And I can stop the theorem right here, or the proof of the theorem. It is valid, but I want to point out something. Why should B be 0? You always want, forget want, you need L of 0 to equal 0. But L of 0 in our case is, well, it's A times the 0 vector plus B. Well, and it turns out that the 0 vector in R1 is 0. So you get 0 plus B, which is equal to B. And you want that to be 0. So long before I started this proof, I'm like, hey, B must be 0. Why? Because it's a line. We're talking about lines. And L of 0 has to be 0. It needs to go through 0, 0. Okay, it needs to go through that point, and that's where B is 0, and here, I know that B is not 0. So I always knew that B had to be 0. That completes this video, but first I want to ask you to please subscribe to my channel if you like videos like this. Subscribe to my channel if you don't like videos like this. Most of all, please watch and learn and leave some comments for me to read. See you in the next video.